Okay, so we will now discuss over here is about your parity check. What is parity checking? Well, parity checking is one of the error detection method that you use while you're transferring data from devices to devices or computers to computers. It's one of the methods that is used by computers and devices. So first of all, you should know it's used for error detection. It's one of the way that is used to establish connection between devices to transferring data. So parity check, obviously, is an error detection method. It will be used by checking the parity bit which is allocated leftmost. We'll just talk about it. There are two methods through which computer and devices can transfer, which is odd parity or even parity. The entire concept of parity checking was generated through the concept first initially of handshaking. So handshaking is a concept that means when computers or devices, when they want to start communication, they first of all have to set the transmission protocol either to odd or even. Now, what do we mean by that? So by odd or even, we mean is that whenever you have is bit, we will have is a parity bit. Remember one thing, your parity bit that you have is not your data bit. When we talk about data bit, these are your data bits, okay? So these are data bits, that's your parity bit. Now, let's say computer A wants to transfer data to computer B. We will obviously first make sure that are we going to receive the data in even or odd. If the computers or the devices have been set to receive the data in odd, what we'll do is we'll make sure that the data we're getting, all of that has to be received in odd. Odd means the number of ones. So you can see over here is in this particular case that the number of ones I have over here is 1, 2, 3. 3 basically is odd. So the parity bit that I will add, the leftmost, I'll make it 1. I can make it 1 or I can make it 0. If I make it 1, now I have is 1, 2, 3, 4, right? Okay. So in case of 4 now, I've been able to establish is even parity. Agreed. So I'll be able to communicate. Now I can transfer it to computer B and computer B will check the protocol. Okay, fine. The parity has been set into 4 by checking the parity bit as well and to receive the data. Well, obviously, if odd were the settings, we would turn this into a 0. If we turn into a 0, our odd parity agreement would be there because we'll have 3 ones. So we look at ones actually. So you can see over here is they have given some example. If we are using even parity, you can see over here this is not even. So this is your parity bit. I told you it's not your data bit. It's an extra bit that has been added for handshaking process to make sure data transmission can take place without any transmission error. So in order to make it even, you see over here I have 1, 2, 3, 4. So 4, if I would have added 1, it wouldn't odd. So I will leave it at 0. If I leave it at 0, the ones are even. The ones over here 1, 2, 3, 4, 5 odd. So I add 1 over here in my parity bit becomes even. I can transfer it. So on and so. Okay. This basically over here I have 1, 2, 3, 4. Right. So if I add 1 over here, this becomes odd again. So I will not be able to transfer. So this is the way your parity checking actually takes place. It's one of the way for detection of errors during transmission of data.